Alrighty, good morning. Welcome to a new week. And bonjour and so on. Alrighty, so I got PA1 graded. Really nice job on PA1. So, a lot of the submissions I saw were just absolutely perfect. Like, no issues at all, which is great. So, PA1 was really about trying to, get a basic framework for a class put together and call some methods, do some constructions, things like that. Different mindset, right? Different way of thinking about things. Um, so it looks like people are pretty well through that transition. There's obviously potential issues with the reduced function. That's always a little tricky, and division by zero and things like that. But by and large, look like people did a great job with PA1. So that was really good to see. How is PA2 coming along? Any major reflections, concerns? All right, cool. So those are all things I'm planning on going over today, which is looking at hash maps, looking at scanners and how we use that to open a file and do input. So so we'll go through all of that right now. And so if yeah, physics can be a time thief. If PA1 is still feeling elusive, if you didn't get something working that you were trying to get working, or you're not sure why it worked, right? Definitely come by office hours and let's go through your code and see what's what. Keep working on the command line. I know some people have been using IDEs. You're going to learn this stuff better if you're typing it in typically VI. On the command line, it's going to force you to internalize, the structure of a class declaration, the structure of a main method, and so on. Then you don't have to, memorize that stuff before an exam or an interview or whatever, right? It's going to become more internalized. So keep working with that stuff. Make yourself notes. Do you guys not like that physics takes a good 40 hours a week? You should do summer of physics. Summer of physics, I think, is actually like 40 hours a week in class. That's PSU's physics offering over the summer. You can do all 3 quarters of calculus-based physics in one summer at PSU, and it's like the only thing you do that summer. I mean, you get to like eat lunch partway through, but it's a pretty intense immersive program. But I think it would be a great way to do physics personally, because it's like that's the only thing in your life, for that. Um, all right, so let's start with scanners. And let's see how we use scanners to read a file. And let's review scanners from standard in while we're here. All right, so first thing is we need to do an import. So we're going to import Java utility scanner. Yeah. All right, so let's just read from standard in, and then we'll modulate that to read from a file. So scanner SC equals new scanner. And we'll read from standard in. And let's use has next. So has next is going to read a word at a time, basically, a token at a time. So we'll read in the next word. And we'll print it out. And then at the end of this, I'm going to clean up my resources. So I'm going to say sc.close. Okay, so sc is system.in is like standard in. It's a thing that we can ingest input from. And we are saying, let's make a scanner. So what's a scanner? It's a thing that lets you ingest in some sort of controlled way. Okay, so system.in, we can think of that as like, you know, FP, if we say file star FP, or if we do that standard in at the end of an fgets call and C, that's where we're trying to read from. But scanner is basically kind of putting some structure around that input stream so that we can do things like say, hey, is there another word available? And if there is, show me what that next word is. And, you know, we already played with this using scanner.hasNextLine and nextLine, which read in an entire line at a time. But we can also say, you know, is there another double? Is there a byte? Is there a Boolean? Is there a big integer? Right? We can use this the way that we would use scanf, for example, and say, you know, give me the next integer followed by a word, right? So, so here we're just using next, which should give us what's called a token. So if I type in, you know, input to standard in, this is a test. Each time that I call has next and next, it's picking up one of these words. All right, so hello. How are you? And so, you know, it's stuff separated by white space. Hello, comma is a word. How are is a word. You question mark is a word. Right? So for PA2, you're trying to process words, and you're going to only consider strings consisting of letters. So your cleanup word method would, you know, change this into uppercase hello. It would leave this as how, are, and this would become uppercase YOU without the question mark. So this is tokenizing your input, right? It's just basically breaking it up into things separated by spaces. And if I run this on, you know, my Java file, I get, you know, the individual words in there. Yeah, very much like the parsing assignment from 224. All right, so to modify this to read from a file, not too difficult. Instead of using system.in, we're just going to say new file, and I'll just say test.txt. All right, that's all there really is to it for the most part. So instead of system.in, we say new file, test.txt. So what is file? File is another class, right? Everything is a class. File is a class. We can construct it with a path name, and it basically gives us access to the contents of a file. Now, once we have a file, we can do things like, you know, see if the file is readable, see if it's writable. We can compare it to another file. We can get the absolute path name. So if we opened it with a relative path name like test.txt, we can get /home, /nic, /etc., right? And you've got all these methods available. Well, it turns out that a scanner can be constructed with a file. It can be constructed with an input stream, that's what system.in is, but we're just going to construct it with a file. So this is going to construct a file object, right, corresponding to test.txt, and then use that as the argument to the constructor for a scanner. And this is pretty typical in Java or other object-oriented programming languages. We're making an object here. We're never really like doing anything with that except passing it to a constructor in this case, right? I'm not saving this in a file object. I could say file f equals new file, and then, you know, scanner sc equals new scanner parentheses f, right? But I don't care about that file object other than giving it to scanner, so I'm just putting it in one line like this. Garbage collector, we don't have to free resources, right? So that'll just get taken care of. So this is basically going to work, except it's not going to compile. So the first problem is it doesn't know what file is. So file is something that has to be imported, and it comes from java.io. So we import that. It's still not going to compile, because now it's telling us unreported exception, file not found exception. Alright, so if you look at the scanner class, and you look at the constructor, down here at the bottom it says throws file not found exception if source is not found. If there's no file in here called test.txt or it's not accessible, this will give us an error. And we've got to manage errors in Java. We can't just let the error happen and it throws up on our screen. Do you import libraries into the main class or just into class files as you need them? So you do an import in a file to say in this file, when I say, you know, something like scanner, this is the scanner that I mean. So it's kind of file by file. It's not really doing anything beyond the scope of this. All right, so exceptions. There's lots of things that can cause exceptions in programming. Division by zero, for example. Things that we may not be able to manage ahead of time. Like if you've got something that's doing division, you don't know if the person is going to put in a denominator of 0, right? An array going out of bounds will generate an exception, or trying to index an array with a negative index will give an exception. Trying to open a file through a scanner when the file isn't accessible, that will give an exception. So there's a mechanism in Java for handling exceptions. And so these are called try-catch blocks. And they look like this. So you've got some statement here which might cause an exception, right? An error. So what you do is you put that inside a different block. It's like a while block or a for block or an if block. It's called a try block. So you say try curly bracket, and you put your statement in between the curly brackets. And if this statement succeeds, no problem. Business as usual. But if it fails, what you do after you've put in the try block, you put the keyword catch. And then this looks kind of like we're declaring a method or a function, right? It's not, but we say catch, and we can put down a type of exception, and we can just say exception, and the name of a variable, an object, and typically it's E. And this block is, you come here if an exception happens. And you can put whatever you want in that block. All right, so try this statement, and if it fails, if it generates an exception, we'll come down here to this catch block. Okay, that's the most basic try-catch block. We can do a lot more, but that's a good starting point. So let's do this. We'll try this. and we'll say error accessing file, and we'll just return. So if we come down here, we know we got through our try block, no error occurred, so we did not execute the catch block, which means we didn't return. So we're down here, this scanner construction must have succeeded. And so we're good to go. Alright, this is also not going to compile, but for a different reason. So if I try to compile this, I'm going to get a message saying, cannot find symbol SC at line 16. And this happens all the time. IDEs will do this also sometimes. I'm trying to use this object SC, and it's saying it doesn't know what that is. Well, I define SC to be a scanner right here, but this is where we get into scoping. Okay, so scope of variables, or scope of objects. Let's call it scope of symbols. Right? Inside a method, variables that I declare inside there are local to that method. Inside a for loop, if I say for parentheses, integer I equals 0, I is only meaningful inside that for block, right? Same thing with try blocks or catch blocks. Since I declared SC to be a scanner inside this try block, that object basically is inaccessible once I get out of this block of code. So the really quick simple fix for that, declare your variable outside of that block and then just give it a value inside the block. Does that make sense? Alright, so now we can compile this up. Let's go ahead and run it. And it says error accessing file. Right? Well, I don't happen to have a test.txt in here. I have a test. But if it exists, then it opens up the file, it reads in the input, and so on and so forth. All right, so that's how you can read from a file. And this, you know, is just a string, and it can be a relative path name, or it can be the whole path from the beginning. Controversial opinion. I love the prequels. I'm way behind on the chat, I think. I missed something. Ah, yes. Yeah, that is it's a controversial subject, I guess. All right. So, and this exception, this argument, if you like, to the catch block, E is an exception. So what is an exception? Guess what? It's a class. Right? It's a class of Java language exception, Java lang throwable. And it's got all these different subclasses, and it's got different things we can do inside an exception. We can call any of these methods. So we can say print the stack trace, or get the stack trace, or get the message, and so on and so forth. So if we get rid of our test.txt and we run this, it just said error accessing file. Suppose you wanted more information than that, right? So what we could do is we could say something like this. We could print out this argument E that was, you know, passed to the catch block, we can print that out, and that'll have more information for us about what particular exception was thrown. So if I run this and I try to open test.txt, which doesn't exist, now we get the message, you know, Java IO file not found exception, test.txt, no such file or directory. And if I make this file and I make it inaccessible, it tells me error accessing file, file not found exception, permission denied. So you got lots of good information available in here, and we can also print the stack trace. Alright, so that's a method inside this object E, which is an object of type exception, which when it was constructed, in response to our exception, filled in information about the context in which the exception occurred. Right, so there's a stack trace. So the error happened at line 11 in main, and it actually came from line 611 in the scanner .java file. And that was calling file input stream, line 138, and so on and so forth. Let's see. A question not about Anakin. How do we access a file that is typed into the command line? Yes, so you can pick it up from arg bracket 1. And yes, definitely close the files that you open in PA2. Anytime you open a file, when you're done with it, close it. Doesn't really make a whole lot of difference on Linux. Windows sometimes still seems to only want one thing to open a file at a time for some reason. But you always want to free up your resources, so yeah, do a close. SC close will close the file. So let's and you can use a file name, or you can use a full path, or it can be, you know, a complex relative path. You can use dots and all the stuff that you normally have available in Linux works in here. So let's go with a command line. So let's open the file specified on the command line. So we'll do args bracket 1. What do we got in here? Oh, test.text isn't readable. Let's do test.java. Oh, my bad. Alright, so Java main, and I'm giving it an argument of test.java, and there you go. So I can do tilde/.bashrc, and there's my bashrc file. So this works pretty well. Yeah, there's a weird cat command. And you know, if you try to run this and I don't have an argument, I'm getting an exception, right? In this case, my exception is array index out of bounds. Well, you know, I could check that first. So I could check args.length. Right, so now I'll be explicit about this. And if I run that, that's incorrect. And if I run this with too many file names, that'll be incorrect. And if I run it with just one, it'll do the right thing. Why is it args bracket 0? So args is an array of command line arguments. So it's kind of like argc, right? Except that the first element is not the name of the program. It's actually the first command line argument. So if I say Java main ABC, right? Args bracket 0 is A, B is bracket 1, bracket 2 is C. So it doesn't seem to include the program name itself as one of those, which, you know, is probably a good thing. Where we're storing each word in when we read each word, the hash map. So yeah, so for PA2, as you read a word, you're going to basically add it to your hash map. We're doing hash maps next. So that, you know, here's your index. So this is test, right? Those get stored somewhere in the hash map, and each of these is pointing to a linked list. All right, so making more sense on scanners and files. Yeah, this test is a what? All right, and like I say, if you don't want to go down this road, right, you can just redirect from standard in for the time being. But it's really just, you know, adding a try catch statement. You know, a try before that and a catch block. Keep your try blocks as small as possible. Inevitably, someone will say, oh, all I got to do is put my whole thing inside one giant try block and I never have to think about it again. Yeah, that's technically true, but don't do that, okay? That's considered really poor form. Because the reason that you have to put try catch blocks in your code is because, you know, most exceptions should not occur. And if an exception occurs, what is it? It's exceptional, right? It's something you weren't expecting to have happen. Usually there's something in particular you want to do in response to that, other than just say, you know, goodbye. So yeah, technically you can make one try block and put your entire, you know, 5,000 lines of code inside there. Really, really, really don't do that. Okay, that'll get you uninvited from lunches at work for a day or two. No, but make your try blocks, just put them around the line of code that you think might throw an exception. Okay. There should be a try block. All right, so let's play with hash maps. So hash maps, we've looked at these before, right? You construct them with two types of things, and multiple methods, but primarily for us, get and put, and maybe is something a member of that. So contains. So let's make a map.java. let's see. Should we make a hash map of rectangles? Hash map of triangles. Okay, I'm gonna have to pull those from. Wow, we made a really fancy triangle class. Can we construct with multiple things? Alright, so there's our triangle class. No errors, good. Giving up the love for the triangles, excellent. Alright, so let's put them in a hash map. Alright, so we construct by saying hash map, that's the type of object that we want, but we have to put in angle brackets the values for these two generic types, K and V, so the key and the value. So let's make a hash map of strings and triangles. So angle bracket string comma try, and I'm just going to call my hash map map. And I'm going to construct it, and when you construct, you also need to specify the types of objects for the key and value pair. And then I'm not going to pass any arguments, so it's just paren paren. So that syntax is a little goofy looking, but we only really have to do it once. So let's put something in to our hash map. So we're going to use put, and we put in a key and a value pair. So map.put. So what should we call our first triangle? Anakin. And Anakin's going to be a 2x3 triangle. Alright, give me another one. Obi-Wan. And Obi-Wan is obviously 1x1. Luke. Mace Windu. Yoda. Okay. Not Yoda, Windu. Alright, I'm just going to do one more. Go with the high ground. Alright, so let's let's make some better shapes. So Luke, I don't know. Luke feels like a 5 by 2 triangle to me. Mace Windu, 2 by 2. Yoda is can we have negative dimensions? And the high ground. All right. So you know, what the heck are we doing here? We're just making a hash map. We've got keys, right? And we've got values associated with them. And so what are we going to do about this? Let's see if it compiles first. It compiles. Okay. So let's print this out. All right, let's just print this out by using its implicit toString method and concatenating to the words the map equals. All right, so what do we have in our hash map? Mace Windu is a 2 by 2 triangle, Luke is a 5 by 2 triangle, Yoda is a 100 by 100 triangle, and so on and so forth. All right, now for us, instead of a triangle, this is going to be a linked list of integers. And the words are going to be, you know, words that you ingest from using your scanner.next method, and then you run through your cleanup word and make sure it's not empty. But, you know, there you go. So we can start exploring these methods. So we could... let's change Yoda. And we'll change Yoda's dimensions here. And we'll print out the map after we do that. What did I just do? I don't know what I did. Alright, so we're going to change Yoda's dimensions by just doing a put in there, and we're going to print out the map again. Alright, so originally there's our old map, and Yoda is 100 by 100, and when we print the map again, Yoda is now 10,000 by 99,000. Alright, so there you go. Skyrim is awesome, but don't ever kill a chicken, man. You know, you can kill just about every other creature in there. You can steal things. You can, like, sit in the Jarl's chair and all this stuff. Don't kill the chickens. Get the whole town after you for the rest of the game. So you know, what does put do? Well, it's not like, you know, putting something in an array or a linked list. If the key is already stored in the hash map and you put a value associated with that key, it replaces it. Right? We're not going to have to do that here, but, you know, for other applications that's useful. So if you just want to associate a value with a key, you can just say put. And if the key is not found in the map already, it'll create a place for it. And if it is found already, it will replace the value associated with the new value. Alright, so we can put methods in there, we can search for methods, we can remove methods, and so on and so forth. So what else can I tell you about HashMaps? Okay. Yeah, I haven't played Skyrim in a long time. So questions about maps. Oh yes, yes, yes. Okay, so yeah, let's talk about iterators. So hash maps are the classic case where, you know, if you wanted to go through systematically and look at each of the things in your map, there's no clear way to do that. We can't say you get the first thing, second thing, third thing, right? So we need to use an iterator for this. Um, and we don't need to do that for PA2. Okay, for PA2, you need to be able to go in with a word and see if it's in the map. So you can say, you know, map.get, and it'll return null if that key is not stored in there. Otherwise, it'll return, you know, for us a triangle, but for PA2 a linked list. Right, so you need to be able to do that. You need to be able to know how many things are in your hash map, and that's just size. So, you know, your method for a number of words is really just returning index.size, right? It's a one-line method. But if we want to iterate, we need to use this this iterator method. So let's see. Do I want to get into that right now? So what you want to do is return a set, which will give you a set of keys, and then you can make an iterator over that. So if you look at the set class, you can get an iterator. And if you look at the iterator class, guess what? It's got a hasNext and a next method. So we call keys. So let's go ahead and do this. I'm performing without a safety net here, but that's okay. Let's iterate over the keys. All right, so we want a set of strings. Key set. Single constructor in our inertia class will do nothing in particular. Does that really mean nothing? I think your single constructor, I don't know if it has to actually do anything. I guess you should probably set a flag saying that we haven't yet processed a file, right? So you probably want a Boolean flag that tells you if you've successfully run the process file command, and that should be initialized to false. I think you can do that in the class declaration, but you could set it explicitly in the constructor. And yeah, because you actually construct the hash map when you're processing the file, right? Open the file, make sure you can access it through a scanner, and if you can, then create a hash map, start ingesting the words, clean them up, add those to the hash map, and so on. So I don't think the constructor. I don't think you can put imports into try. So try is executable code, so it has to go inside a method typically. But maybe there's an Easter egg if you put your imports in there. I don't know. And I've never tried importing something that doesn't exist. I assume you get a compile error. All right, so let's make a set of strings called keys, which is map.keyset, and then let's make an iterator it equals, and we'll get an iterator from our set. Like that. Just really need to have a type. All right, so then we're going to basically do has next and next pair. So just like when we're reading words from a scanner. Well, iterator has next, that tells us there's another key available. And then I'm just going to save that in a string called this key. So it next will return the next iterator that's available. And we can go ahead and print that out. Next key is all right. So that's our basic setup for iterating. We got 2 minutes left. I might have time to set up the imports and try this. So get a key set, right, which is a method inside the hash map. That gives us a set. And then that set we can call the iterator method. That gives us an iterator. And then the iterator we can say has next next. So sets I need to import. So that's Java util, and sets are Java util. This time we're going to get syntax errors. Oh no, we didn't. Okay. Hey, wow, can't believe that worked. All right. So yeah, so we went through and our iterator gave us you know, our keys one at a time. And then we could use those, you know, to access the corresponding values and so on and so forth. And the order of this is not, you know, significant in any way we understand. So we put in Anakin, Obi-Wan, Luke, and Anakin is down here, Obi-Wan, and Luke is way up here. So it's probably, if it's storing these things in an array, it's probably going through the array in order and pulling them out there, but we can't expect it to be the same order that we put them in, and we can't expect the order to always be the same, right? So if I were to remove Yoda and then put Yoda back in, it might end up in the same place, it might end up somewhere different, right? All you're guaranteed with an iterator is that it will give you each thing in the set over which you're iterating exactly once, right? And then what?
Question before we kick off, Nick.
Yeah. Go for it.
Why do we have to put semicolons after the imports?
I don't know if you do. Because semicolons are expected. I don't know if there's a better rhyme or reason, but apparently they are important. I do Python once in a while, and I put semicolons after statements, and they're not required, but they don't do any harm there either. But yeah, I guess they are required on imports too. Yes, because Java says so, that's right. Alright, so we're out of time. I will post these two pieces of code on the shared code area right now. Keep digging in PA2, and I will see you tomorrow.